Everybody hear me okay? I had to lower the mics so that they didn't run into my beard. So today's talk is comparing apples to apples, or apples to Apple. Jake in the last talk was nice enough to say that 500 times, which is cool. It's like he was prepping for me. So my name's Adam Mathis. A little background. So I came from doing a lot of work in a lot of different security domains and IT domains, vulnerability management, security engineering, penetration testing, all this fun stuff. But I worked in an environment where there wasn't a lot of Apple systems. And then I switched companies and started working with a lot of companies all over the various spectrum, and a lot of them were very Apple focused. And I started trying to figure out, well, how's the best way to defend these systems? And what I found is there wasn't a lot of research being put into Apple systems, not a lot of tooling, and so I said, well, let's start looking at how we can get better in this space. So the idea of this talk, kind of like the way it's going to work, is we're going to look at certain tactics and techniques on the Windows side, and then give you the corollary on the macOS side. So kind of giving you a baseline foundation of how to find enemy tradecraft on Mac systems. And I work for Red Canary down the bottom. So we're going to go over kind of the pillars of the Mac security ecosystem, and then we'll talk about some individual pieces of tradecraft and how to catch it, some detection ideas, and then we'll go into some tooling and a little project that I'm working on. So when we look at the Apple ecosystem, and that kind of that encompasses iOS, watchOS, tvOS. All of these things are starting to kind of converge, although Apple will say they're not. You're starting to see more and more things come from iOS into the macOS world. And a lot of these things are kind of playing out across all of these different products. So really, Apple focuses on three main pillars for their security, and all of their subsystems kind of interlace together to enforce these things. So there's code signing, so verifying that something has a legitimate code signature. Entitlements, so even if something is signed and it's running under a privileged user, such as root, there are certain things that you cannot do in an Apple system, such as query an individual process by its PID or its process ID, or various other modifications to protected system files. Unless you have very specific entitlements given to you by Apple at the time of the compilation of the binary, you're not going to be able to perform some of these activities. And a lot of those, since they have to go through an Apple pipeline where they have to sign everything for you and validate the entitlements you're requesting, it's very difficult to get a binary on a system with privileged entitlements without subverting some of these security systems. And then sandboxing. So the disallowment of one process from talking to another. Everything has its own little happy place. Most of that stuff is coming through a pipeline of the Apple Store. So all of these things together makes it really, really toxic for adversaries that want to bring their own binaries to the table, which is why it's fun to talk about living off the land. Most of the tactics and techniques we're going to talk about here are things you can do with native Apple binaries. But just to start off with, just to kind of give you a little taste of what this will look like, so on the Windows side, you have PowerShell, and you've probably seen some talks today where they go into depth about how PowerShell is used for evil in a lot of environments. On the Apple side, the corollary for PowerShell is AppleScript. So AppleScript is Apple's scripting language that allows you to not only run things in terminals, it allows you to interact with applications both behind the scenes and graphically. You can click buttons, you can enter text into text box. So if you're thinking from an attacker standpoint, you can do massive amounts of evil with this thing. And it's a lot of fun, and we'll go into some demos of how you can do some AppleScript evil. But also, there's Bash on Apple systems, Python, Ruby, Perl, PHP, and then also optionally PowerShell. So Apple basically sets us up and says, hey, any framework that anyone would ever want to bring to the table, let's just let them run it natively. Now all these things live on the Apple system by default. If you remove them, you will probably break some Apple subsystems. So it's just to keep in mind that if someone wants to bring a Ruby framework or some Python script, you're probably just going to run it on your system without any hindrance. So just a little bit about taxonomy and kind of how we're going to focus on this. So at the top, we have kind of the MITRE ATT&CK framework reference. If you're familiar with MITRE ATT&CK, or if you're not familiar with MITRE ATT&CK, it's a nice, open, free, vendor-neutral document, or wiki rather, of adversary tactics and tradecraft techniques, the tools they use. It's a great way to kind of figure out like who are the evil people and what are the things they're doing when they get on systems. So if you haven't heard of it, it's a great way both as an attacker and or a defender to use this as a foundation for what are the things I need to hunt for, what are the things I need to be detecting, what are the things I need to be using for attack. And then at the bottom we have the Mandiant attack lifecycle. This is just kind of another way to describe what adversaries do when they get on your network. We're going to focus primarily in that loop there because that's where the bad guys are going to spend the most time. There's obviously, there's growing ways every single day to compromise a system initially to get access to it. But what we've seen is that most bad guys, when they get on a system, they do the same things. They're lazy, just like everyone else. So they want to use the same tools that they use it everywhere else. They want to persist the same way. So that's kind of where we're going to focus on this talk. So to start off with, let's look at discovery tactics. So on the Windows side, we have who am I exe. On the Apple side, we have who am I. Pretty straightforward. For the Windows side, we have net, which is a great tool for admins as well as bad guys to look and see, okay, what is this, what user is, am I looking at? What kind of groups are they in? Information on like domain groups. It's very useful. On the Apple side, you can perform those same types of queries against users and groups using DSCL and DSCacheUtil. On the Windows side, there's a utility called MSInfo. On the Apple side, there's a neat utility called System Profiler. And what System Profiler does is it collects just a boatload of information. So it gives you not only installed software, gives you like firewall rules that are enabled, all this kind of information on groups, lots of information on hardware, on your kernel. There's just like a ton of discovery information that you can get just by running this one simple command. And as you can see, if you can see on that diagram there, this is an actual example of an exploited system where someone had embedded a macro in an Excel document and executed it. And so what it did is run a bunch of scripts to collect information on the system. And the one there is using System Profiler and specifically querying for like one section of the System Profiler data. So lots and lots of information. If you just run that by itself without any kind of command line syntax, you'll get crazy amount of data. And so if you're familiar with Nmap, Nmap is obviously not a Windows exclusive, but obviously it's kind of one of the de facto port scanners. So Apple has a little known port scan utility baked right into the operating system called Stroke. It is a subsystem used by the Network Utility app, which is kind of a little known built-in app by Apple. But what it allows you to do is, normally if you go into the Network Utility app, you can go and say, hey, here's an IP I want to look at, here's the ports I want to scan between. But you can also run it directly from the command line. So this is a great one to look for in any environment just because most people don't know it's there to start out with. And there's almost no legitimate uses to calling it directly from the command line like this. So, all right, let's get into something a little more exciting. So credential access and privilege escalation. So on the Windows side, if you use the DOS key command or in a terminal, you can, I think it's F7 is the hotkey. You can kind of see the history of a DOS command window. And on the Mac side, because they use Bash, you can query the Bash history file, which allows you to see all of the commands that have been executed by the user that you're running under the context. Now, of course, you can look at the Bash history of any user on the box, provided you have the correct privileges. Each user has their own Bash history file. But in there, you can find things like, what are the systems that this user is talking to? And that might help you, if you're an attacker, figure out what other systems do I already have access to, either by virtue of the fact that they're using some identity file, which is that second line there, If they're pointing to an identity file that has a username and password to pass along to the destination server? Or is it just something that there's already keys set up for? So SSH keys, so I can just immediately pivot to the next box. There's other ways that you can kind of escalate your privilege, like on the Windows side, you have the concept of DLL hijacking. So that's if you have a piece of software that's going to look for a specific dynamic library, you can sometimes take a maliciously crafted library and drop it directly in the same folder. And if the application is not coded very well, they may just take whatever library they see first. So like, oh, I have my DLL right here. I don't have to go look anywhere else. And now all of a sudden, they're running terrible code in a signed app. In this case, the same exact principle exists on the Mac side. This is actually a utility called, I think it's just called DLL Hijack search. And this is something written by Patrick Wardle at Objective-C. It's a great tool. Actually, Objective-C.com is a great place to find all kinds of Mac utilities. So definitely check that one out too. And then another way to kind of escalate your privilege and gain access to credentials is to just ask the user to give them, their password. So in this case, this is actually an AppleScript command. You can see here that we're telling the system preferences application to pop up a box and say, hey, I need your password to install system updates. And then that's going to pass that back to your shell. And it looks like this. So we're just going to paste this in here. We execute it. That's legitimate system preferences. The user types in their password. And they hit OK, and that passes it along to the shell. So in most cases, the actor is going to have kind of a hidden shell from the user, either like through a reverse shell or something like that. So it wouldn't be quite as visible to them. In this case, jump to the next there. So there's a utility called Eggshell, or it's a post-exploit framework written in Python specifically for Mac. It's a surveillance-based framework, so there's a little bit of execution, but mostly it's there to collect audio, visual, file type information on the victim. And so this is kind of what that looks like there. So they prompt the box, the user types in there, it goes back along the reverse shell, and then immediately you can escalate to root. For the most part, if you have an Apple system and you have one user on it, that person is an admin by default. So in a lot of places, a lot of organizations, they don't necessarily think to change that. So you can turn a normal user into root, which is kind of like the god of the computer, very, very quickly. So down here at the bottom, just a quick detection win. So look for OSAScript. If you just look for OSAScript, in general, if you have a lot of Mac in your environment, you might see this a lot because AppleScript is used by a lot of legitimate utilities to perform actions in the background. But it's one of those situations where if you're looking for command lines that include the system preferences app or the word password, anything like that is going to be highly suspect. So another one, so if you're familiar with Mimikatz or Keychain or all these other ways you can kind of extract clear passwords or even sometimes encrypted passwords, there's a kind of a corollary on the Mac side in the way of Keychain access. So the Keychain in the Mac world is kind of it's a database full of all of your secrets, and not just your passwords. It can be certificates, it can be all kinds of different identity information. Basically, Apple will be very helpful. If you say, hey, I'm starting to type in a password to a system, it's like, do you want me to store that in Keychain for you? And you say yes, and now it's in this database, which is secure. So how do you access that secure database? You can access it directly from the command line with the security app. And basically, there's a bunch of different switches you can use with security. This one is find internet password, which does what you think it does. So if you have saved passwords for any sites, like your banking information or any internal web apps that you might be using, you can query those directly. So another thing down here, the second one is dump the keychain. So you can dump everything out of the keychain into just a text file. So both of these can be called from the command line. Apple did add some, they did add some security around this. So when you run these commands, there will be a physical box that pops up that you have to type your password into to say, okay, yes, I agree that I wanted this password to be removed or collected by this process. But there are some other ways that you can subvert this. So Patrick Wardle from Objective-C, he wrote a great blog post on using mouse keys, which are basically synthetic ways to move the mouse and click buttons, just using keyboard input. So there are definitely ways to get around some of these things. So just looking for the process of security will probably give you a lot of false positives because access to the keychain is used by a lot of different processes in the Apple world. But looking for anything that's trying to find a password or dump the keychain, there's almost no legitimate apps. I actually have never seen a legitimate app that would do either one of these. So those are great switches to look for to find evil. The other way to get access to the keychain is just to steal it. It is just a file that exists on your endpoint. So you can just copy that thing live over to another system. And then when you move it to a second Mac, if you already have that password and you go to open it up, it's just going to say, hey, what's the password to this keychain? You give them the user's password. You have all of their passwords. It's very quiet. It's much quieter than the first method. So just looking for any way to any process at all that's not security, that's looking at any of those keychain database files. Or any kind of file modification involving one of those database files. So those are good ones. It is also possible as a preventative measure, you can actually change the password to your keychain to be different than your login password, which is definitely recommended in almost every case, just because that gives them another level that they have to bypass to get access to those secrets. All right, so for lateral movement, so a lot of you might be familiar with PSExec. There are obviously a lot of other ways to move laterally in a Windows system, Windows environment, but that's one of the more popular ones because you just point at a system and say, go do this thing, and it will go do it. And we can do this, again, with AppleScript, which is cool. So in this case, AppleScript is telling the application terminal. So it's opening up a terminal window, and then it's saying, run this script. And so with this case, you can imagine you can pretty much run any kind of script you want, any kind of bash script, any kind of Python script. You can run that directly from AppleScript. So in this case, we're going to tell it to open an SSH session to a remote system, wait a couple of seconds so we can authenticate, and then run a second script, which is going to open calculator in the current tab. Run this, it's going to open that second one, enter the password, boom, calc is popped. So that's in that other one. So you can run whatever you want. You can run any kind of script, any kind of application behind the scenes. And that's a neat little way just to move onto another system. But you can also do that with more directly with AppleScript. So if you'll see here at the bottom, this little picture, this remote Apple events is disabled by default, but using AppleScript, you can turn it on. So if you reach out to a system like we just did in that last demo and say, hey, go and open this up and start clicking this button and turn this thing on, now you can use AppleScript to just reach out and directly touch that machine. So in this case, you can see AppleScript says, tell this application on this remote system to open this application. Which is, obviously way easier from an attacker standpoint. So other ways to detect AppleScript, especially with remote commands, any kind of AppleScript with a network connection, it's not a very common function that you'll ever see. And anything, any kind of OSA script execution with a command line of do shell script or do script. Both of those are indicative of trying to run some other kind of scripting language, which is uncommon. So persistence, there's a lot of different ways people can persist in Apple land. So the startup folder on Windows, there used to be a corollary on the Apple side called library startup items. It's deprecated, but it still is honored. So if you put something in that folder on a system, even if it doesn't exist and you create it and you put something there, it will still be honored. So any kind of file modification to that folder is highly suspect because that's going to either be someone who is trying to do something evil or an incredibly old piece of software. Services are kind of like launch daemons, so in the fact that they execute without the presence of a user. So they don't necessarily need a user. Whereas something like your run keys on the Windows side, the run keys, the run once, the things that are specific to a user or specific to a user logging in, that's going to be the launch agents. And both of those exist, in different places on the Apple system. There's actually many different locations those can live in, but there are also some really good tools. So Objective-C, Patrick Worrell, he has a tool called Knock Knock that will look at these and a lot of other persistence mechanisms on Mac. And then scheduled tasks, we have cron jobs. If you're familiar with the Linux world, cron jobs are just a way to run a task on a schedule. And then launch CTL is one that's kind of Apple specific, and it's kind of interesting. It's one where you can execute code and it will run as a job and it will continue to run until that job is killed or the system is rebooted. So it's kind of a nice way to run something and ensure it runs, and then as soon as the system's rebooted, cleans up after itself. And that looks kind of like this. So we're going to run launchctl. We're going to open up a Python script. You'll notice that popped up a box. That's just kind of a visual. It doesn't necessarily pop up a box on its own. But right there, where I'm moving my mouse frantically, it comes back. And so no matter how many times I click that OK button to make it go away, it's going to continue to run. So imagine a Python script, like most of them, that does not have a pop-up box. It's just running in the background. And even if someone does, they look and see, what are my running processes? Oh, there's some Python, let's kill it. You kill it, it's going to come right back. So it's definitely one to look for. In any kind of launch CTL, especially with a submit as a command line, that's definitely something worth looking at. So how do you gain visibility to your Mac systems? So there was a gentleman that had a talk earlier today about OS Query. It was excellent. Definitely should go back and watch that recording. Just kind of the ins and outs of how to start using OS Query for hunting for evil in your environment. It is retroactive, so you can run queries against your systems over and over again to get kind of up-to-date information, but it's not really a real-time monitoring tool. It's not really meant to be one. But it's a great way to find persistence and all other kinds of things on your network. Super Odda is one I really like, written by Jonathan Levin. This is a real-time tool. He basically reversed PR audit from old Unix fame and came up with a better implementation for Mac. And so it can either output in this format that you see down here or in JSON, and it has native syslog, so you can pipe that up to any kind of system that you want. So that's definitely worth looking at. And then Nouman is one of the more recent systems that came to the table this year. This is an open source, so totally open source. It's another real-time monitoring. It was very process focused to start out with. They've recently added some network visibility. It's definitely one to look out for in the future. And then some other useful tools if you're trying to protect your Mac systems. So LittleSnitch and MicroSnitch, those are firewalls. There's a process-oriented firewall in LittleSnitch. MicroSnitch tells you if your microphone or your video go hot, which is very useful if you're not expecting that stuff to happen. So if someone is trying to spy on you, you will see these little eyes and ears go live and let you know that something bad's happening. And then I mentioned Objective-C a couple of times. Lots of great tools out there. So I wrote a little script. The idea being it's never going to replace OS Query, or it's not really meant to. But if you're in an environment where you have a handful of Macs and you don't necessarily want to go through all the trouble of getting a new vendor product approved, or not vendor product, but another product approved to install on them, this is just a bash script. So you can deploy this with SSH, and it basically what it will do is just give you information on users, groups, known persistence mechanisms, just a lot of information so you can kind of get a baseline of your systems. It's still very alpha, so if you go look at it, please don't judge me. Please feel free to add whatever you want. I'm not very good at code, but I do make stuff that works occasionally. So go check that out if you would like. And that's me. So any questions? Yes, sir. Yeah, they'll be out there somewhere, for sure. Absolutely. And you can come get a prize since you asked a question. Yeah. Absolutely. Any other questions? Hint, hint. Guy with the glasses. It's a long walk.
Is there any sort of tools for iOS intersection or just looking into those?
So there probably are. iOS is not really my forte specifically. I know that, so when I mentioned Eggshell as like an attacker's tool, that absolutely works for both macOS and iOS. So from a defender standpoint, I'm sure there's more stuff out there that I'm aware of, but Eggshell can do a lot of damage on iOS. And you also, sir, get a prize. Anyone else? Yes, ma'am. Can you ask that one more time? I'm sorry.
During your build process, you know, and say you migrated from Windows to an Apple environment, what did you find the most difficult in migrating from that between those environments?
It's a very different environment. Just the down to the most basic levels. Mac shares a lot with BSD, so if you come from a Linux environment, there's a lot more corollaries there. But there's a lot of newness that you have to learn with Mac. So it was really just, luckily I had a lot of Linux, so I just thought of it like a Linux system with better support. so it was okay in that respect.
Have you seen these tactics in a while?
Yes. Yeah. So some more than others. So the discovery ones are the ones we see most commonly.